So LeetCode 1463 cherry pickup 2. So you are positioned in a grid representing a field of cherries, and every grid represents the number of cherries in that cell, right? And what you need to return is you need to return the maximum number of cherries that you can collect by using these two robots. So every robot can just move down, they cannot go back up, and they can either go to the left, stay in their same column, or go to the right. And they have to stay in the bounds of the grid, obviously. Okay, so to solve this, you just use DP. Like, there comes a point where the solutions, if some problem is just DP, then it's an easy problem. Because like, all you have to do here is try all of the combinations. There's no like insane strategy that gives you the optimal path. You just need to try them all. And the only thing that you need to care about is you want to cache the results that you already have. And one way of understanding this is like, let's say that I told you the best path, like I say, okay, so if you go down here, the best amount of cherries that you're going to be able to pick up is like 10 or something like that, right? And then I tell you that if you go here, then the maximum amount of cherries is going to be 15, something like that. Well, knowing that is going to be pretty easy to understand what is the move that you need to do. So just by having a recursive solution with caching, you can basically solve this optimally, because you just need to try all of the possibilities. So yeah, let's just jump into the implementation. So you just want to take the grid length and you want to take the rows and the columns, right? So you store those into two variables, and then you have your function call. So this is going to be our main function, and the parameters are the row. So this is just always in sync. It's not like you move one of the two robots before the other, right? You always keep them in the same row. And then you have the first robot column and the second robot column. Okay, so these are the parameters of our function. And what our function is going to have to do is it's going to have to check if these parameters are in bounds or not. Because if they are out of bounds, this is just the generic check to see if they are in bounds. If they are out of bounds, then you need to return 0. Because what's the best amount of cherries that you can collect if you go out of the grid? It's 0, right? Okay, so that's like kind of our base case, okay? And now what you need to do is you need to set up all of your recursive calls. So the first thing that you want to do is you want to check how many cherries you can collect in this position, where these are the parameters. So surely you can at least take this amount of cherries, and then it's possible that you can also take this amount of cherries if the two columns are different. Because if the robots are on the same cell, then you can only have one of them take the cherries. So if the column 1 is equal to the column 2, you want to multiply this by 0, basically. So this is just one-liner way of saying collect the cherries in the two robots' positions, but only collect it once if the columns are equal, okay? Or you could unwrap this in some if-else conditions. It's up to you. Okay, now you want to set up, so this is the amount of cherries that we collect in the current position. But now we want to know, okay, how about all of the remaining cells going downwards, right? So we're going to have some recursive calls to the same function going downwards. And so you start with a maximum of 0. So this is the max amount of cherries that you can collect by going downwards with respect to the current position, right? And then you have two loops, but anyways, we're going to have two loops here, but first of all, let's just define our return value. Our return value is going to be the amount of cherries that we can collect in the current position plus the maximum amount of cherries that we can collect going down from the current position, right? Okay, so yeah, this is just going to be our return value. And now we just need to update our maximum values with all of the possible combinations. So the only thing that is sure is that you need to go downwards. So that's the only thing that you know. Now you do not know if you want to move the robot number 1 to the right or to the left. You don't know if you want to have it stay put. You don't know how you want to move the robot 2. So you just try all of the possibilities. That's why these kind of problems are easier than they seem. You just try all of the possibilities. So these are all of the possibilities to change the column of the robot 1, and these are all of the possibilities of changing the position, the column of the robot 2. And you just do for every possibility of changing the column of the robot 1, change all of the possible ways the column of the robot 2, and check if that improves your maximum amount of cherries collected from downwards, from this position on downwards. Okay, so you update your maximum value if you have a value greater than its current value, right? And yeah, you just recursively call your best from position. Obviously, you increment row by 1, and then here you can see that we are now calling it on every possible combination of column changes for each of the 2 robots. And that's it. So this solution will already be correct. It's just that we are calculating more times that we need. So for example, if we call best from position on row 1, column 2, and column 2, 3. Okay, so we have like 1, 2, 3, something like that. Then it's not like if we call it again, we're going to get the same result, right? Because the best from a starting position doesn't change in between calls. There's nothing changing here. It's all static data. There are no updates to the cell values. So what that tells you is that you can cache the results. You can keep them in a map so that you do not have to calculate them again. So we're going to do that. We're going to have a cache. And at the beginning, we're going to define a key. I'm going to implement this function later on. So this is just a key that takes the parameters and gives something like a string, a number, something that identifies this triplet of keys, right? And then you just check if in your cache, you look up into your cache with the key, and if it is not undefined, meaning that it is defined, then you just return that, right? Because why would you ever calculate it again? You already have the result in the cache, so there's no point in calculating it again, right? And now at the end, you want to make sure to also remember to update the cache. So instead of just returning, you return the assignment, which actually returns the right value. And so you return the assignment to the cache key of the result of your computations, right? And now all that's left is to implement the toKey function. So the toKey function just needs to, it can be anything. You can implement this yourself. It just needs to be some unique values given this triplet of values. So in my implementation, I just made a string, and I have a random separator here. You can replace this separator with anything you want, really. It can be any character, or you could have some way of calculating an integer from these 3 parameters. But it doesn't really matter. All that matters is that it works. And yeah, I just wanted to demystify this problem. It's not that hard. You just try all of the possibilities. It's not magic. You just try all of them and you take the best one by doing a math.max, right? So that's it from me today. Thank you for watching, and bye.